Ethane has two tetrahedral methyl groups, connected by a single carbon-carbon sigma bond, and its lowest energy shape is the staggered conformation, where the hydrogens on one methyl group are rotated, so they sit between the hydrogens on the other methyl group, minimizing torsional strain. Think of each carbon as a tiny pyramid, with 3 hydrogen atoms at the corners and 1 bond to the other carbon at the top, and that makes each methyl group tetrahedral. When the 2 pyramids are joined, they can rotate around the carbon-carbon bond like 2 linked gears. In the staggered arrangement, the hydrogen atoms on one side are not lined up with the hydrogens on the other side, but are instead offset, so each hydrogen is between 2 hydrogens on the opposite carbon, and this spacing reduces repulsion between the electron clouds in the bonds. The alternative is the eclipsed arrangement, where hydrogens line up with each other, and that increases torsional strain because bonding electrons are closer together, so the staggered form is lower in energy. Rotation around the single bond is relatively free at room temperature, so molecules spend most of their time near the staggered geometry. Students often think the carbons are flat instead of tetrahedral, which misses the 3-dimensional shape. So picture a pyramid, not a triangle, and remember each carbon has 4 bonds pointing to the corners of a tetrahedron. Another common mistake is imagining the staggered form is locked and never changes, but the bond can rotate, and the molecule moves between conformations, with the staggered being most favorable. The tip is to think in terms of energy and repulsion, not rigid shapes. Some learners mix up which hydrogens are offset in the staggered form, so it helps to draw 2 circles for the methyl groups and show one rotated so the marks are between the other marks to visualize the offset. For more videos and resources on molecular shapes and conformations, visit www.gumballdegree.com.